Hello guys, how are you? कैसे हैं बच्चे लोग? This is your KP sir on YouTube again. So myself Krishna Prakash. Students love to call me KP sir or EE sir. I have 16 years of teaching experience, trained more than 150 batches, and worked in all top coaching centers in India. Now in Unacademy online platform, I am going to teach environmental engineering, hydrology, irrigation, construction materials and open channel flow. So if you want to watch my free classes on Unacademy, you just search NVLK Prakash. You will get my free classes, watch the lectures, and if you want to join plus course, paid full length course of GATE and ESE, use the code KP Civil. You will get maximum discount and all the benefits provided for you. Use the code, don't forget what is the code, KP Civil. Use the code KP Civil, then take plus subscription. You will enjoy all the benefits. You will enjoy the full length GATE and ESE subject. Now coming to the today's session, it is related to previous year question solution, PYQ session for 2016 GATE examination from the subject of open channel flow, civil engineering from the subject of open channel flow. We are going ahead to learn open channel flow. Very important point I would like to tell here. Set 1 consists of only one question. Set 2 consists of 3 questions in this open channel flow for 2016. Very easy and simple questions they have provided, but one big very lengthy question. We'll go through it and we'll analyze, and I will explain each and every question in a simple and sweet manner. Okay?
Hey, I will challenge you in PUBG. Will you come online to play?
No, I have online GATE class. I don't want to miss it.
Who is teaching?
Top faculty of civil engineering in India, KP sir on Unacademy. I am a big fan of his teachings.
Oh yes, I have also heard about KP sir. I am willing to join the class.
It's nice. Take subscription in Unacademy using KP Civil code. You will be benefited more. Okay, let's crack it.
First question. The pre-jump fraud number for a particular flow. Pre-jump fraud number. What you can say regarding pre-jump fraud number? FR1. Pre-jump fraud number always is FR1, fraud number 1. For a particular flow in a horizontal rectangular channel is 10. For a horizontal rectangular channel is 10. Ratio of sequent depth. And it was mentioned clearly. Post jump depth to pre-jump depth ratio required. What is post jump depth to pre-jump depth? Y2 by Y1. So you go and use Bellinger momentum equation. We know it now. Sequent depth ratio, post jump to pre-jump depth ratio, 1 by 2 into minus 1 plus under the root of 1 plus 8 into FR1 square. Direct formula substitution question only. Bellinger momentum equation, direct formula substitution question. I repeated several times in my classes. The most important equation we are expecting mostly questions from this formula. Y2 by Y1 post jump by pre-jump is equal to half 1 by 2 into minus 1 plus under the root of 1 plus 8 into FR1 square. So remaining is simple formula substitution only. You take it directly. 1 by 2 half minus 1 plus under the root of 1 plus 8 into 10 square. FR1 is given. FR1 is 10. Just 10 square. So you calculate it. Easy na? Simple and easy question. Direct. Easily you got 1 mark from this question. So what is the answer? 13.651 sequent depth ratio, post jump to pre-jump ratio, y2 by y1 13.651 post jump to pre-jump ratio. We'll move on. A 4 meter wide rectangular channel. Okay, 4 meter width of the channel, write down B is equal to width of the channel, write down B is equal to 4 meter. Having a bed slope of 0.001, having a bed slope means we write down S naught, 0.001 S naught, bed slope of 0.001, carries a discharge of 16 meter cube per second. Q, capital Q, discharge 16 meter cube per second. Consider Manning's roughness coefficient N. Manning's roughness coefficient 0.012. Acceleration due to gravity Z 10. Category of the channel slope is. Category of the channel slope is. So if you want to consider category of channel slope, as per given options, if you write, for a horizontal, you consider S naught is equal to 0 and normal depth Yn is equal to infinity. S naught is given 0.001 value provided in S naught. So it is not horizontal. Neglect it. Option A eliminated. Na? For a horizontal slope, channel bed is equal to datum. S naught is equal to 0. Yn is equal to infinity. So horizontal slope not happened. That is eliminated. Option A eliminated. For mild slope, you can prove normal depth greater than critical depth, S naught less than SC. Normal depth greater than critical depth, S naught minus FC. If any one is proved, your question is completed. For critical condition, Yn is equal to Yc. Critical depth and normal depth are same. S naught, Sc are same. Yn is equal to Yc, S naught is equal to Sc for critical depth, critical slope condition. Last one, steepy sloping surface. For steepy sloping surface, normal depth less than critical depth, S naught greater than Sc. So if you prove any one condition, your question is completed. From the given data, if you prove any one condition, your question is easily completed. For it, what you need first? Critical depth is required now, Yc. Yc is needed now. For any condition, first Yc is needed now. Yc is easy. Q square by GB square whole power 1 by 3. Q square by GB square whole power 1 by 3, that is Yc. Q16 square, G10, B4 square whole power 1 by 3. Calculate it. So relation between normal depth and critical depth I am deriving now. First critical depth value we are getting capital Q square by GB square whole power 1 by 3. Substituted the values and we are getting critical depth as 1.16 meter. Yc value is 1.16 meter. Okay. Then you need normal depth. So to derive normal depth, use Q is equal to AV. Continuity equation. Use continuity equation. Q is equal to AV. For area, I am writing B into Yn. width into normal depth, b into yn. Velocity, I am using Manning's equation, 1 by n r power 2 by 3 s naught to the power 1 by 2. Q is equal to b into yn into 1 by n r power 2 by 3 s to the power 1 by 2. Velocity according to Manning's equation. And it was mentioned wide rectangular channel. For a wide rectangular channel, what is R? For a wide rectangular channel, I am writing R is equal to, as per channel geometry equations, BYN area perimeter B plus 2YN. Wetted area by wetted perimeter A by P. Hydraulic mean radius is equal to area by perimeter. Wetted area by wetted perimeter. Area BYN, perimeter B plus 2YN. Now I am substituting here. BYN into 1 by N. Then in place of R, BYN divided by B plus 2YN whole power 2 by 3 s naught to the power 1 by 2. Now I am substituting the values. I am going to substitute the values. B 4 meters, yn required into 1 by, what is Manning's coefficient? 0.012. 1 by 0.012. B 4 into yn, 4 divided by 4 plus 2yn whole power 2 by 3. S is given 0.001. 0.001 whole power 1 by 2. Discharge also provided the value 16. Discharge also provided the value 16. So I am going to write this. I am going to write this equation like this. You can write down like this. 16 by 4. What is 16 by 4? 4 into 0.012. It is coming here. It is coming denominator. 16 by 4 is 4. 0.012 is multiplied, divided by root of 0.001 is equal to. So this is taken out here. This is taken out. And this is also taken to denominator. Now, it is remaining 4 into yn divided by 4 plus 2yn whole power 2 by 3. 4 into yn divided by 4 plus 2yn whole power 2 by 3. If I am going to solve for this, what I am getting? I am writing here 4 into, sorry, one more yn is here, yn into 4 into yn into 4 into yn, 4 plus 2yn whole power 2 by 3, which is multiplied with yn is equal to, I am calculating that value, and that value got, this value is obtained 1.55. Calculate it, you will get same 1.55. So 4 into yn by 4 plus 2yn whole power 2 by 3 into yn is equal to 1.55. So just assume yn is equal to yc. Take it as 1.16. So you got now already yc. YC you derived now. Yn is equal to YC. YC you got it now 1.16. That 1.16 meter is taken. Then substitute in it. 4 into 1.16 divided by 4 plus 2 into 1.16 whole power 2 by 3 into 1.16. If you solve this, you are getting 0.81. So you are getting 0.81. It is not 1.55. Na? It is not 1.55. Na? It is wrong. So yn not equal to yc. So yn not equal to yc means second condition, third condition, critical slope. This is cancelled. Yn not equal to yc, critical slope not cancelled. Got the point? You understand the point? You are assuming yn is equal to yc, and in this place of yn you are substituting 1.16 meter. If you substitute, you got the value 0.81, but you need to get 1.5. So if you want to get 1.55, if to get 1.55, so what should be yn value? Tell me, to get 1.55, what should be yn value? Yn must be greater than yc. If it is less than yc, you won't get that. 1.55 you won't get if yn is less than yc. If yn is greater than yc only, you will get this. So what is the slope? Yn is greater than yc. What is the slope? Mild slope. Mild slope. So answer is B. Mild slope now yn greater than yc. S not less than yc. So you consider to get the final value of 1.55, yn must be greater than 1.16. Then only you will get 1.55. Yn is greater than yc, critical slope, sorry, critical depth. Yn is greater than critical depth, so it is a mild slope. Next question. A hydraulically efficient trapezoidal channel section. I would like to tell you one point here. Hydraulically efficient trapezoidal channel section. What is hydraulically efficient trapezoidal channel section? It is half of hexagon. Always hydraulically efficient channel section is exactly half of hexagon. Exactly, it is exactly half of hexagon. Hydraulically efficient channel section with angle of 60 degrees here. Angle of 60 degrees here. Now, uniform flow depth of 2 meter. This section is carrying uniform flow depth of 2 meter. Bed width of the channel. Bed width of the channel. For a hydraulically efficient trapezoidal channel section, which is exactly half of a regular hexagon, bed width of channel, tell me, bed width of channel is equal to inclined slope. Bed width of the channel is equal to inclined slope. How you will get inclined slope now? We have the formula, it is angle of 60 degrees now. Sin 60 is equal to flow depth by inclined slope. Sin 60 is equal to flow depth by inclined slope. So now what can I write down? Inclined slope or bed width, both will be same now. I have written clearly. Inclined slope is equal to bed width is equal to y by sin 60. What is y? Y is equal to 2 divided by sin 60. You are getting the answer? Simple question. 2 by sin 60. The only one point you need to know. Hydraulically efficient trapezoidal channel section is half of hexagon. Sin 60 is equal to y by inclined slope. And very important point. inclined slope is equal to bed width. 2 by sin 60 you will get 2.31 meter. 2.31 meter, very simple, 2.31. Okay, we'll move on now. We'll go ahead. It is a very simple question. If you know channel geometry, question is easily completed.
Hey, I will challenge you in PUBG. Will you come online to play?
No, I have online GATE class. I don't want to miss it.
Who is teaching?
Top faculty of civil engineering in India, KP sir on Unacademy. I am a big fan of his teachings.
Oh yes, I have also heard about KP sir. I am willing to join the class.
It's nice. Take subscription in Unacademy using KP Civil Code. You will be benefited more. Okay, let's crack it.
3 meter wide rectangular channel. Width is equal to 3 meter. Carries a flow of 6 meter cube per second. Discharge is equal to 6 meter cube per second. The depth of flow at section P is 0.5 meter. Depth of flow at a particular section P, YP. Depth of flow at a particular section, take it YP, 0.5 meter. A flat topped hump is to be placed at the downstream of the section P. So after section P, so consider this is section P. A flat topped hump is to be provided. A flat topped hump is to be provided at the downstream of section P. Assume negligible energy loss. In between section P and the hump, energy loss is 0. G is equal to 9.81. Maximum height of hump. This height of hump to be achieved. Clear? Maximum height of hump to be achieved, which will not change the depth of flow. Very important. Depth of flow not going to change. Like that you can design the height of hump. I will make it very simple for this. So energy loss is negligible. No? Energy at point P, E1 is equal to critical energy plus depth of hump. That delta Z max now we are considering here as maximum height of hump. Clear? Whatever delta Z max you are getting here, that is now considered as maximum height of hump. Maximum height of hump. So what is the delta Z max now? Maximum height of hump delta Z max is equal to E1 minus EC. So you have to derive critical energy and energy at P, both. E1 is energy at P, EC is critical energy. So you have to get E1 is equal to Y1 plus V1 square by 2G. Y1 is nothing but YP 0.5. Y1 is nothing but YP 0.5. And V, velocity is needed. Velocity is equal to discharge by area. Area I will take By. Q by By. Velocity is equal to Q by By. Q is 6. B is 3 meter into 0.5. We'll get the velocity now. Velocity is equal to 4 meter per second. Q by By. Q is 6 meter cube per second. B is 3 meter. Y is 0.5. 4 meter per second. So 4 square by 2 into 9.81. 4 square by 2 into 9.81. 0.5 plus 4 square by 2 into 9.81. You are getting E1 1.315 meter. Energy at P E1. Energy at P1 1.315 meter. If you want EC, what is EC formula? EC, critical energy, is equal to 3 by 2 YC, critical depth. So see, all the formulas are one by one interlinked to one another. If you need critical energy, you need critical depth. You need normal energy, you need normal flow depth. So EC is equal to, for a wide rectangular channel, EC is equal to 3 by 2 YC. So 3 by 2 YC formula, already we solved previous question. 3 by 2 into Q square by GB square whole power 1 by 3. Q square by GB square whole power 1 by 3. Substitute it now. EC is equal to 3 by 2. Q 6 square. G 9.81. B, what is B? 3 meter. 3 square whole power 1 by 3. Whole power 1 by 3. Then what is EC? EC is critical energy. Now you are getting, calculate 3 by 2 into 6 square by 9.81 into 3 square whole power 1 by 3. What you are getting? 1.112 meter. 1.112 meter. Now height of jump. Delta Z max only na? Height of hump delta Z max. 1.315 minus 1.112 meter, which is given as 0.203. Which is given as 0.203 meter. You understand it now? Height of the hump 1.315 minus 1.112. This is equal to 0.203 meter. That is the answer. You write here. You write here. Finished now? Completed. So only 2 typical questions remaining are very simple and easy questions. Hope you enjoyed the lesson.